This is number 20 on page 495 of our textbook, where we're asked to find all fourth roots of j. And of course that means we're going to use the formula that I have in the yellow box at the top of the screen here. So the first thing we want to recognize is that the number j is a complex number. Now remember, a complex number has both a real part and an imaginary part. The real part is x, the imaginary part is y. Well, in our case, we have just a j. There is no number displayed in front of j, so we know that that number is a 1. So that means that our imaginary part y is 1. The real part, though, there is no real part to that number. We weren't given 2 plus j or 5 minus j. It was just j. So that means that our imaginary part is 0. So if we write the number j in rectangular form, x plus yj, it would be the number 0 plus 1j. Now let's picture on the complex plane where 0 plus 1j would be. 0 is my real part. That means we don't move either right nor left on the horizontal axis, which is the real axis. But 1 is my imaginary part, and that means we go up 1 on the imaginary axis, the vertical axis. So the point 0, 1 is clearly at 90 degrees on our unit circle, or pi over 2 on our unit circle. But I know that on the final exam we're going to be doing this problem in degrees, so I'm going to identify that my angle theta is 90 degrees. So what I know is that theta is 90 degrees. I also know that my radius, the distance from the center to my point here at 90 degrees, is 1, because it's 1 unit away. N is the roots that I'm wanting to find. And so I am wanting to find fourth roots of j, so n is going to be 4. Now, when we're using this formula, we use the formula for all values of k beginning with 0, and in this case, since we're finding fourth roots, we need 4 values of k. So we'll do it with 0, with 1, with 2, and with 3. But we'll do it with 0, and then we'll show you a little shortcut for continuing on from there. So I want to start by plugging in our theta and n in all of the places that it belongs, or they belong. So z sub k equals the nth root of r. That would be the fourth root of 1. Times the quantity. Cosine of theta over n, which would be 90 over 4. Plus, now the version of the formula that I have displayed here is in radians. I am doing this in degrees, so instead of adding 2k pi over n, we add 360k. Whoops. So that'll be plus 360k over 4 instead. So that'll be my generic formula that I'll be using for every value of k here. Now my first value of k, again, we know we use 0. Well, if you replace k with 0, you'll be adding 360 times 0 over 4, which means you're going to be adding 0 to your angle measure 90 over 4. Forgot the parentheses around here. So my angle measure in this case for my first fourth root of j is just going to be whatever 90 divided by 4 is, and that's 22.5 degrees. So z sub 0 will equal the fourth root of 1, which is 1, times the cosine of 22.5 degrees plus I times the sine of 22.5 degrees. Now we don't recognize 22.5 degrees as one of the angles, critical angles on our unit circle. And therefore we'll use our calculator to calculate this cosine and sine. Make sure your mode is in degrees and you'll get a cosine of 22.5. Well, 1, the radius out here, or fourth root of the radius out here times anything, is going to give us what we get. So cosine of 22.5 degrees is 0.924 plus I times the sine of 22.5 degrees, which is 0.383. Here is our first fourth root of j. Now, to find the remaining 3 fourth roots of j, what we want to look at is just this portion of the formula. If I put a 1 in for k, I'll have 360 times 1, which is 360, divided by 4, which is 90 degrees. Every time I put a new number in for k, the angle measure that I previously had is going to go up by 90 degrees. So in other words, for my second fourth root of j, I'm going to take the angle measure, 22.5 degrees, and add 90 to it. So if I add 90 to 22.5, I get 112.5 degrees. So z sub 1 is going to be the fourth root of 1, which is 1, times the cosine of 112.5 degrees, plus I times the sine of 112.5 degrees. So again, I recognize that 112.5 degrees is not one of my critical angles on the unit circle, so I use my calculator with my mode in radians, and my second fourth root of j, and I happen to use I here, I and j are interchangeable, I get the cosine of 112.5 degrees to be negative 0.383, and the sine of 112.5 degrees to be positive 0.924. Oops. And I know that the sine has an I attached to it. So I have my second fourth root of j, or I. My third fourth root of j, I add 90 degrees to my previous angle measure, and now I am at 202.5 degrees. When I find the cosine of 202.5 degrees, I get negative 0.924. When I calculate the sine of 202.5 degrees, I get negative 0.383. So there's my third fourth root of I or j. My fourth, I'm going to add 90 degrees to my previous angle measure, and now I've got 292.5 degrees. So the cosine of 292.5 is 0.383, and the sine of 292.5 degrees is negative 0.924. There are my 4 fourth roots of j, or I. Again, all I needed to do once I found the first one was just identify the value of 360 over n, which in our case was 4. 360 over 4 is 90. That tells me that all of these angle measures are 90 more than the previous angle measure.